On this occasion of the official launch of ELIONA, which is the supercomputer of the Nagaland State Disaster Management Authority. Now, today's launch is an important milestone for NSDMA and also for the state as such, because ELIONA represents a major step forward in strengthening our capacity for disaster preparedness, early warning, scientific analysis, and evidence based decision making. As we are all aware, and we have seen all around us also throughout the world, disasters or risks have become very complex and quite unpredictable. Whatever knowledge we have relied upon to predict disasters based on the data that we have for the past many decades, somehow that is not coming true in recent times that you have noticed. So, this ELIONA will help us equip ourselves with advanced tools and technologies to actually support timely and informed action. And this ELIONA has been established as part of the Nagaland Center for Disaster Management and Atmospheric Research. And as you could see, once we have inaugurated it, launched it, it's a powerful computational platform for weather modeling. Basically, they are doing the most important thing, and climate risk analysis. And also, this is going to do a lot of satellite data processing. And inbuilt in it is artificial intelligence applications is also there. So all this will enable to come up with indicators regarding the weather that we would like to constantly map and understand how it's going to play out in the state. So it's not only a big technological asset, if you look at that way, but also a very important decision support system for building a very safe and more resilient Nagaland. So on behalf of the Home Department and NSDMA, again, I extend my sincere gratitude to the Honorable Advisor NSDMA and also for our Honorable Advisor CWD for joining us on this occasion. I also warmly welcome the Chief Secretary, senior officials from other departments also, including from the NSDMA itself, the technical staff, and the media personnel. And I wish this, after this launch, this ELIONA, the way it works, I mean, I wish this entire team who has tried to bring it together and make this happen a grand success. Thank you.
ELIONA is a native climate and disaster resilient supercomputing platform. The name ELIONA is derived from a Hebrew origin, meaning God is gracious or God has answered. Symbolically, ELIONA represents the convergence of intelligence, foresight, resilience, and technological advancement for safeguarding humanity against the emerging climate and disaster risk. The systems overview that I would like to share with ELIONA is a next generation AI accelerated high performing computing infrastructure, which is engineered for hyperscale climate intelligence, AI driven atmospheric modeling, real time disaster analytics, geospatial risk computation, autonomous simulations ecosystems, and predictive disaster governance. It is developed under the Nagaland State Disaster Management Authority. ELIONA will serve as a computational backbone for weather and climate modeling, 3D digital hazard intelligence, then Earth observations analytics, disaster simulations framework, AI and ML scientific research, and decision intelligence systems. ELIONA is also architected to function as a multi-domain computational engine capable of integrating atmospheric science, geospatial intelligence, AI neural forecasting, big data analytics, remote sensing, and disaster governance framework. The core computational mission we are looking at from reactive response to predictive intelligence. So this ELIONA is designed to transform disaster management through AI-enhanced forecasting, real-time data assimilations, the predictive hazard intelligence, autonomous risk analytics, and simulations driven. This platform also will enable a real-time weather prediction, climate anomaly detection, terrain-aware hazard modeling, which we are already doing it for already 7 district headquarters. These are disaster impact simulations, and dynamic risk computations, and AI-assisted operational forecasting. ELIONA ISO will optimize high resolutions weather modeling. We are looking at 25 kilometers square for weather predictions. And this is not really happening today in the world, but we are looking at achieving that through the scalability. Then neural weather predictions, then generative climate simulations, AI-driven, multi-source data fusion, and geospatial deep learning, and digital twin risk mapping. I think that even the prime ministers has made a digital twin of all the cities in the country. And we are also looking at autonomous scientific computations. So there are core domains. We have weather intelligence. Um, Even the monsoon analytics will happen there. And we are also looking at storm trajectory modeling. And in the climate intelligence, we are looking at long-range climate projections and carbon and even environmental analytics. When we talk about the climate risk or green gas house emissions, we are looking at that carbon and environmental analytics as well. We are also looking at hazard intelligence through landslide susceptibility mapping. Our sensors are there. We will show you later. And seismic risk analytics that we are happening. Somehow today, because of some connectivity, we are still trying to rectify Meluri Center, but 2 centers are working. And geospatial intelligence, we will be showing you afterwards how we are monitoring the cloud above us through the satellite data. And we are also looking at the disasters intelligence, like predictive emergency modeling. That's what we are looking at it. So ELIONA is a digital brain, which is a system designed to continuously ingest, learn, simulate, predict, optimize, and support autonomous intelligence operations. Now, our strategic vision, we want to establish ELIONA as one of the India's leading AI-powered climate and disaster intelligence supercomputer platforms, enabling predictive governance, scientific resilience, and autonomous disaster intelligence for future generations. So this is the overall infrastructures architect of this supercomputer and our future scalability. On this very day, I would also like to specially mention our previous chief secretary who called us and told us, what do you want to do under the special, what is that project, state special innovative funding. Nah? So he has really ignited to begin this. Now, if you really look at the component, this is a CPU architecture which has 2,000 to 5,000 CPU cores. This is for high volume data injections and pre and post processing and simulations orchestrations. Then the GPU infrastructure, we have 50 to 200, but this is scalable. And this is mainly for artificial intelligence and machine learning model training. Now, here in this, we have not used any other foreign large language modeling, LLM. We are going to develop our own large language modeling here. We are looking at our local software developers. I'm told Nagaland University has a good lab, so we are trying to link with that and then come up with our own LLM for the artificial intelligence and machine learning. The memory that we have here, the high bandwidth, we are having 32 to 64 GB high bandwidth memory per CPU. We are also looking at 5 to 10 petabytes non-volatile memory express. So this is what we are looking at it. The interconnectivity, we have the nervous link this is for ultra low latencies GPU. So this is the overall infrastructures of this supercomputer. Thank you very much, our honorable advisors who are here, Chief Secretary, who is present here and all the other officers who are here. And this is the profile of supercomputer. Thank you so very much. The World Meteorological Organization's weather standard. We also having a new land there. We have connected in all the 17 districts, so we can see the live weather through our installed camera there. Now, this is the weather data which is being processed, satellite data which is being processed from the supercomputer, this one. This is the data processing it, and this is the front end. This is how we can see, which is being processed from here. In India, there will be only few computers who will be able to get access to this outcome. And this is another weather systems that we have already installed, which is predicting it for our weather. This is the live front end that we are looking at it. This data processing is being run here behind, connected to this server. And we are also not looking at storing all our weather data, our climate data elsewhere in the cloud, because that is going to be transported to the foreign source. So we are all housed here, so that ours is purely protected. Our data are purely protected, and no third party is able to access to it. Now, some people may ask, if there is an earthquake and if this crash, we have our own server systems there, like
ELIONA. With its advanced computing capacity, ELIONA will enable NSDMA and the government to process large volumes of data relating to weather, terrain, climate, and disasters. But most importantly, to my mind, it will also be used for weather modeling, hazard mapping, and predictive purposes. I have been telling the NSDMA and departments related to disaster management that yes, it is good to do humanitarian service, provide relief after a disaster has struck. But I feel the more important part is we should be able to predict and mitigate disasters before it happens. I think this is what should be at the core of the functions of NSDMA. So I'm happy that we are launching the supercomputer ELIONA, and with the large amount of data that will be generated, that data should just not lie locked in some files. Based on the data available and the analysis made, we should allocate the resources that are available with the NSDMA, which I feel is not small. So I look to the future where NSDMA would take more proactive steps in preventing disasters.
I hereby launch ELIONA supercomputer for Nagaland State Disaster Management Authority. I'm really happy today for the official launch of ELONA, the supercomputer of Nagaland State Disaster Management Authority. This is a proud and important moment for NSDMA, the Home Department, and the government of Nagaland. The launch of ELONA marked a significant step in our effort to strengthen disaster preparedness, climate resilience, scientific research, and technology-based governance in the state. Nagaland, because of its terrain, rainfall pattern, seismic sensitivity, and exposure to landslide, flash flood, thunderstorm, and other hazard required strong system for monitoring, analysis, early warning, and timely response. As we all are aware that Nagaland is a small state, but we used to say that this disaster used to happen almost throughout the year, starting from February when the wind used to blow. Elona has been established to support this need with its high performance computing capacity. It will enable the processing of large volume of meteorological, satellite, terrain, climate, and disaster-related data. It will support advanced weather modeling, rainfall prediction, landslide and flood analysis, geospatial hazard mapping, climate risk assessment, and artificial intelligence-based application. This facility will also strengthen important initiatives of NSDMA, including the Nagaland State Disaster Management Information System, disaster risk financing, parametric insurance, damage and loss assessment, urban resilient planning, and community-based preparedness. In the coming year, ELIONA can become a major decision support platform for the state helping department and district administration plan better, respond faster, and reduce disaster risks for effectively. However, technology by itself is not a final goal. The real value of ELIONA will be seen when its output reach the field, support district-level decision-making, assist community, and help protect life, livelihood, infrastructure, and public asset. I therefore encourage NSDMA, the line department, technical institution, and all stakeholders to work together and make full use of this platform. I appreciate the effort of the Nagaland State Disaster Authority and the technical teams who have worked hard to bring this initiative to this stage. Their dedication reflects the commitments of the government of Nagaland to adopt modern tools and scientific approaches for disaster risk reductions. As we launch Elona today, I hope this facility will become a strong foundation for improved forecasting, better planning, better assessment, and more resilient development in Nagaland. Let us use this platform not only as a technological achievement, but as a means to serve the people of the state more efficiently and effectively. With this word, I congratulate NSDMA and all the associates with this initiative. I am pleased to formally launch this Elona. Thank you.